Okay, 8.5, rational functions. Before we get started with the problem, let's just go over a few terminology for this section. Okay, the domain of a rational function. A rational function, first of all, is where you're going to have an x in your denominator. Okay, so anything that would have an x in the denominator is going to be a rational function. The domain would be the zeros of the denominator are excluded from the domain, which means anytime you have an x in your denominator, you need to find out what makes that denominator 0 and then exclude that number or numbers from the domain. The next term you need to be familiar with is vertical asymptote. Vertical asymptotes are also zeros of the denominator as long as they are not also zeros of the numerator. Okay, so if you find a 0 of the denominator, it's going to be a vertical asymptote unless it is also a 0 in the numerator. Okay, the horizontal asymptotes. Now, let me tell you what vertical asymptotes would look like. A vertical asymptote is an imaginary vertical line that looks like this, that the graph comes right up next to, but it doesn't touch it. Okay, it just comes right up next to it. Horizontal asymptotes are the same idea, but they are horizontal lines like this. Okay, the degree, the way that you decide what the horizontal asymptote is the degree of the numerator. If it's less than the degree of the denominator, then the horizontal asymptote is simply y equals 0. Okay, so the horizontal line would be at the 0, y equals 0. If the degree of the numerator is equal to the degree of the denominator, then you're going to look at your leading terms, the leading coefficient of the numerator over the leading coefficient of the denominator. So your horizontal asymptote, and it'll make more sense once we get to the problems, will be y equals, again, whatever the leading coefficient of the numerator is over the leading coefficient of the denominator. Now, if the third situation is if the degree of the numerator is greater than the degree of the denominator, then there simply is not a horizontal asymptote. Again, this chart will become more clear once we get to the problems. I just want you to have this terminology down. Okay? The X-Intercepts, or in other words, where the graph crosses or touches the x-axis, are wherever the zeros of the numerator are, as long as they're not also zeros of the denominator. And then the last term is one that we've seen several times before. The y-intercept is wherever the x's are zeros unless it makes the denominator 0. Okay, so now that we have those, let's look at some of these problems. Number 1, we'll say determine the domain of the function. So if you remember, the domain, if you have a rational function with an x in the denominator, it's the 0 of the denominator is what we're going to exclude when we're talking about the domain, which means set this denominator, 3 minus x, equal to 0. That's how you find the 0 of the denominator. We're actually going to say that x is not going to be able to equal this number because whatever makes the denominator 0 needs to be excluded from the domain. So to solve this for x, I could just add the x, put the x on the other side by adding the x. So 3 cannot equal, on this side, I just have x. Okay, now, since x cannot equal 3, because if you'll notice, if you have 3 minus 3, that would cancel out, make your denominator 0. That's what you can't have. Now, to write it in this interval notation, remember interval notation means we're going to use parentheses and infinities and things like that. We want to write that x can be anything but the number 3. So in interval notation, that would mean anything from negative infinity to 3 in union with 3 to infinity. So that would mean any number in the number line except 3. Now, number 2. Same thing, except this one's x squared. And what does that mean? That means it is a quad problem, which means I can go to the quad quad program in my calculator, right? Anytime x squared means I can solve that kind of equation in my quad program. So if I go to program quad, what's my A? My A is 1. My B, the number in front of x, is 2. And my C, which is my constant, is negative 24. Well, that's what those are the zeros. That's what you just found, the zeros of the denominator, which are 4 and negative 6. So we want to say, just like we did in this top one, everything but 3. But now we want to say everything but 4 and negative 6. There's two numbers that will make this denominator equal 0. Those numbers are 4 and negative 6. So if I write that in interval notation, I want to say everything from negative infinity. Now be careful where you put the 4 and negative 6. If you are coming from the far left end of the number line, who are you going to come to first in the number line? The negative 6 or the 4? You would come to negative 6 first. So you want to say negative infinity to negative 6 in union with. So that includes everything below negative 6. This second parenthesis is going to include everything between negative 6 and 4 because those numbers are also fine. Then in union with, so again, everything below negative 6, everything between negative 6 and 4, and now we want to include everything above 4, so 4 to infinity. All right, number 3 says, list all the asymptotes of the following function, then graph the function. So remember, the first thing it's going to ask me for is the vertical asymptote. And what is the vertical asymptote? It's very similar to the domain, the zeros of the denominator, as long as they are not also zeros of, well, you can't even see that, zeros of the denominator that are not also zeros of the numerator. So let's see, the zeros of the denominator, again, it is x squared, which means I can use quad for this. Program, quad. A is the number in front of x squared, so it'll be 1. Now, this is tricky. B, remember, look at this last one. So A was the number in front of x squared, which was 1. B is the number in front of x. Look, the last one had an x, so its B was 2. This one doesn't have an x, so its B is 0. And C is the constant, which is negative 4. So there's the zeros of the denominator. Now, these are where the vertical asymptotes are, which means the vertical asymptotes are vertical lines. When you type in, you're going to want to type an equation. The equation of all vertical lines is simply x equals wherever the vertical lines are, which are at 2 and negative 2. So the vertical asymptotes are x equals 2 and x equals negative 2. Okay, that's what shows the vertical asymptote. What is the equation of the oblique asymptote? Now, the oblique asymptote comes into play in a very special situation where we're not going to see at all this semester. So the oblique asymptotes, there's not ever going to be an oblique asymptote in these problems. It comes when there's a certain degree that is one more than another degree, which we will not see. So there is no oblique asymptote. The horizontal asymptote. Now, this is where we use this chart. So we're talking about the degree of the numerator. So looking at the degree of this one's numerator, since it doesn't have an x, its degree is 0 in the top. The degree of the bottom, the degree is the highest exponent of the polynomial. So since it's a 2, so the degree of the bottom is 2. So let's see where that falls into place. the degree of the numerator is less than the degree of the denominator. That is true. The degree of the numerator is 0. The degree of the denominator is 2, which means the horizontal asymptote is at y equals 0. So the horizontal asymptote is y equals 0. So again, vertical asymptotes will always have the form x equals a number. Horizontal asymptotes have the form y equals a number. Vertical asymptotes come in at zeros of the denominator. Horizontal asymptotes follow this chart. And since the degree of the numerator was less than the degree of the denominator, that told me that the horizontal asymptote on this problem was y equals 0. Now, we want to pick out what this looks like. And you could type this into your calculator, but look, we know that there are horizontal asymptotes, which means these dotted lines at 2 and -2. There's 2 of them. So look, this one has a horizontal asymptote here at 2 and at -2. But look at this one, where it has a horizontal asymptote at -2, but it does not have that horizontal asymptote here at +2. So it's not that one. This one has, I'm saying horizontal, I mean vertical, up and down, vertical. So this one does have vertical asymptotes here and here, so this one's still okay. Now look at this one. It only has a vertical asymptote at -2 and not at +2, so it's not that one. Now, we also know that there is a horizontal asymptote at y equals 0. Okay, again, you can put this, go to your y equals, clear it out, put this in your calculator, 3 over, then in parentheses, x squared minus 4, and graph it. Again, you'll see, look, there is a where the graph doesn't touch, there's a vertical asymptote here at 2 and -2. So there's one at 2, there's one at -2. Now remember, it has a horizontal asymptote that goes through at y equals 0. So there's my y equals 0 right here. So let's look at which one this is showing. Also, you can see this part of the graph down here, which look, it has it here, but not that one. Do you see how these are the ones that look the same? So A. Number 3. All right, list all the asymptotes of the following function, then graph the function. So, vertical asymptotes are going to be the zeros of the denominator. Once again, look, your denominator is x squared, which means you can go straight to the quad. Your A is 1. B is 0, right? Because there is no x to have a number in front of. And then your C is -16. So let's see, my vertical asymptotes. Remember, vertical asymptotes are always x equals a number. So x equals 4 and x equals -4. So there's your vertical asymptotes. Now remember, your horizontal asymptote has to do with the degree of the functions top and bottom. So the degree of the top is 3, the degree of the bottom is 2. Which means there is a horizontal asymptote. There is, oh, this has an oblique asymptote. All right, I just told you there's not supposed to be any oblique asymptotes. So number 4, I'm making a note to take it out of the homework. Wow, so you'll be able to skip that one. I need to remember to take that problem out of the homework list. Okay, so number 4 will not be in your homework list because it does have an oblique asymptote, which it's not supposed to. Number 5. So again, you'll just be able to skip number 4. Number 5, find the vertical asymptote of the graph of the function. Now remember, the vertical asymptote is the 0 of the denominator. So x minus 4 equals 0. Solve it. So you're just left with x equals 4 when you add the 4 to both sides. So x equals 4 is the vertical asymptote. Number 6, same thing. Find the vertical asymptote, which is zeros of the denominator. Once again, it is x squared. So you can again use your quad program anytime you're solving for x squared. So let's go to quad. A is going to be your number in front of the x squared, which is a 1. B is the number in front of x. This time I do have an x. The number in front of it is 4. And then C is your constant. Well, there is nothing back here, so your C is 0 this time. So these numbers right here are the zeros. So x equals 0 and x equals negative 4. So x equals 0, x equals negative 4. Number 7, again, find the vertical asymptote. It's not squared, so it's not quad. Now remember, vertical asymptote is 0 of the denominator. So 3 minus x equals 0. Since it's not quad, it's just regular x, I'm just going to solve it for x by adding that x to the other side. So what are you left with? X equals, on this side you just have the 3. So x equals 3. Number 8, again, vertical asymptote. Look at your two factors. One of them's x plus 2, so we'll set that equal to 0. X minus 4, set that equal to 0. Solve them for x, so subtract the 2's here to get x equals negative 2. Since this is minus 4, add the 4's here to get x equals 4. So x equals negative 2 and x equals 4, which is A. Number 9, another vertical asymptote. So again, it's zeros of the denominator, and then look, since it's x squared, I can just simply go to quad and type in my A, B, and C. A is the number in front of x squared, which is 1. B is the number in front of x, which is negative 4. And C is your constant, which is negative 12. So your vertical asymptotes would be at, now this one you have to be careful. Let's see, 6 and negative 2 are the zeros of the denominator. Now, if you will remember, I'm going to check this one because I do see that the numerator will have zeros also. So let's go back and see. Vertical asymptotes are zeros of the denominator, which we found were 6 and negative 2. So those are the zeros of the denominator. That are not also zeros of the numerator. So if you're looking at this one, you need to make sure that neither of these numbers, 6 and negative 2, are zeros of the denominator. So let's find, the numerator. Let's find the zeros of the numerator, again, using quad since it's x squared. A is 1, B is 5, and C is negative 14. So the zeros of the numerator would be 2 and negative 7. So these are fine. The only time that you would get a number that you wouldn't be able to use is if one of these numbers matched one of these numbers. And since they don't, these are true vertical asymptotes. So x equals 6 and x equals negative 2. So 6 and negative 2. Oh my gosh, y'all are killing me. I'm killing myself. not y. What are the vertical asymptotes? They're always x equals 6 and x equals -2, not y. Those are horizontal asymptotes, are the y's. All right, number 10. Here, determine the vertical asymptote of the graph of the function. Okay, so let's see. First thing we need to do is, it's x cubed, so I can't use quad yet. But look, they all do have an x, which means I can pull an x out, put in parentheses what's left. Well, what do you get if you take an x out of all of those? You will still have 5x squared minus x minus 22. Now, if this right here, this x gives me one of my zeros, x equals 0. I can use quad now on what's left in here to factor it or to solve it to get my zeros. Do you see how now it's x squared? That's when you use your quad program. So go to program quad. Your a is your number in front of x squared. Whoops. Program quad. A is the number in front of x squared, which is 5. B is the number in front of x, which is -1. C is your constant, which is -22. Okay, so type an integer or a simplified fraction. So one of them's good. One of them's -2. So there's another one. X equals -2. Now this other one, since it doesn't want that as a decimal, remember, let's show it, remind you how to turn that decimal into a simplified fraction. Type in whatever decimal you're trying to change, so 2.2. Now go to math. The first thing under math is going to say turn that decimal into a fraction. Do you want to turn 2.2 into a fraction? Yes, which turns it into 11/5. So x equals 11/5. So your three zeros are 11/5, -2, and 0. Now, look at your numerator. Because remember, it's only a vertical asymptote if it's a 0 of the denominator, which these three numbers are, but not also a 0 of the numerator. What is it? If you plugged it in for this x, what would make the numerator be 0? Well, if you plugged in a 0, isn't 0 to the third power 0? It is. So 0 is also a 0 in the numerator, which means it cancels that one out. That's what that means. The vertical asymptotes are zeros of the denominator, which these three are, but they can't also be zeros of the numerator. Since 0 also makes the numerator be 0, then you can't use that. That is actually going to be a hole, what's called a hole in the graph. Okay, so the only vertical asymptotes are at x equals -2 and x equals 11/5. All right, number 11. The next few problems are talking about horizontal asymptotes. Okay, this goes by this chart. All right, so there's my horizontal asymptote chart. So let's see what number 11 is asking us. Number 11 says, determine the horizontal asymptote of the graph. And it has to do, the first thing you look at is the degree of the numerator and the degree of the denominator. That's what differentiates these three things. Because the top one says if the degree of the numerator is less than the degree of the denominator, if the degree of the numerator equals the degree of the denominator, or it's the third situation, if the degree of the numerator is greater than the degree of the denominator. So let's look at these degrees, okay, and which the degrees are just the highest exponent. The degree of this one is 4. The degree of the denominator is also 4. So where do I go if the degrees equal each other? It's this second situation. So let's see what that tells us about our horizontal asymptotes. Since the degrees equal each other, then your horizontal asymptote is y equals the leading coefficient of the numerator. So what's the leading coefficient here? It's a 3 over the leading coefficient of the denominator. Well, what's the leading coefficient of the denominator? It is 5. So that is what that means. If the degrees equal, which they do, then this right here, that y equals 3/5, is where the horizontal asymptote is. All right, number 12 says determine the horizontal asymptote of the following. So let's look at the degrees. The top degree is 2. The bottom degree is 4. So the degree of the numerator is less than the degree of the denominator, which is the first situation. The degree of the numerator was less than the degree of the denominator, which simply means the horizontal asymptote is at y equals 0. Number 13. Let's see, what's the degree of the numerator is 3. The degree of the denominator is 2. So let's see, since the degree of the numerator is greater than the degree of the denominator, so it's this third situation, right? The degree of the numerator was greater than the degree of the denominator, which means there is no horizontal asymptote. So top bigger than bottom, no horizontal asymptote. Okay, number 14. Find the domain, any asymptotes, and the X and Y-intercepts of the function, then graph the function. So let's see, the domain is the zeros of the denominator. So let's see, if I set the denominator and I say x cannot equal 0, because the denominator is simply x. So x cannot equal 0. If I write that in interval notation, what would it be? Anything less than 0 and anything above 0, which is negative infinity to 0 in union with 0 to infinity. Okay, let's see, the X-intercept. If you go back to our notes, let's see what we have for X-intercept. Zeros of the numerator that are not also zeros of the denominator. Let's see. Well, we know the 0 of the denominator is 0. We just found that out. Let's figure out what the 0 of the numerator is this time, which simply means set your numerator, which is 2x plus 1, equal to 0. Solve it for x, so subtract 1. So 2x equals negative 1, divide it by 2. So x equals negative 1/2. And it says type an ordered pair and type an exact answer. So let's see, the X-intercept is at negative, let's see if it doesn't want decimal. Hang on just a second. Oh. No, it wants it just like we have it. X is negative 1/2 0. Because remember, it says type an ordered pair, because that's X-intercept is a point. It's the point at where the graph crosses through the x-axis. So it's going to cross through the x-axis at negative 1/2. The Y-intercept, now here's one that's tricky, because Y-intercepts are turn the x's into zeros, which will be 2 times 0 plus 1 over. Here's where it gets tricky, because look, there's an x in the bottom. So if I turn that into a 0, what that means is the denominator turns into 0, which means there is no y-intercept. It does not cross the y-axis, because when you plug in zeros for x's, it turned the denominator into 0, which just means there is no y-intercept. So let's see. It crosses, so there's no y-intercept. That means it's not going to cross the y-axis. So let's see. This one looks like it crosses the y-axis. And when you're on the computer, you're going to be able to blow these out, so you'll be able to see them bigger. But this one crosses through the y-axis here. So that's not C. Looks like none of the other graphs cross through the y-axis. Now, it does say it crosses through the x-axis. So here's my x-axis. It's crossing through the x-axis at -1/2. Well, here's my x-axis. Look where it crosses through. It looks like it's crossing through on positive there. Look at this one. It crosses through the x-axis right here. Right on the negative side of the 0, which looks like -1/2. This one crosses through the x-axis right on the 0. Okay? Now, let's see. Remember what it also says. Let's see. So this right here, since it crossed through at -1/2, right here. Another problem, same kind of, it's going to ask us all these questions and then ask us to put in the graph. So finding the domain. So what do? The domain is zeros of the denominator. So let's see, since the denominator is squared, to find its zeros, I can go to quad. A is 1. Since there is no x, B is 0. C is -64. So let's see. Those are the numbers that need to be excluded from the domain. So if I'm going to write that in interval notation, like it's asking me, so I cannot have -8 and 8 in my domain, because those are zeros of the denominator. So let's see. I would write that as -infinity to -8 in union with the numbers in between -8 and 8 are fine, so those I can put in. And then the numbers bigger than 8 are fine, so from 8 to infinity. So there's your domain. The X and Y-intercepts. So remember, the X-intercepts are the 0 of the numerator. So let's see, what's the 0 of this numerator? If I set this equal to, there's the zeros of the denominator. I just found that when I was doing the domain. The zeros of the numerator. If I set that equal to 0, x plus 8 equal to 0 to find its 0 and subtract 8. So x equals -8. So the 0 of the numerator is also -8, which means there is no x-intercept. So it's not going to cross the x-axis because there is a 0 in the numerator, but it's also a 0 of the denominator. Do you see how the -8's? Okay, so that just means that it's not going to cross the x-axis there because -8 is not in the domain of this problem. So no x-intercept. Now the y-intercept, if I plug in zeros for x's, let's look at what happens. I have 0 plus 8 over 0 squared minus 64. Well, 0 plus 8 is 8. 0 squared is just 0. So 0 minus 64 is -64. And if I reduce that, a positive over a negative is negative. 8/64 reduces to 1/8. Again, if you are not good at reducing fractions, your calculator will do that. What did I want to reduce? -8 over 64. Hit enter. How do you turn your decimal into a simplified fraction? Math, enter, enter. There it is. So it reduced -8/64 to -1/8. So this is your y-intercept. So let's see. There is no x-intercept because The 0 of the numerator was also a 0 of the denominator, which just means there is no x-intercept. And the y-intercept is at -1/8. So let's go down to C. It's the only one that has that situation. There is no x-intercept, and the y-intercept is, now remember, the y-intercept is a point where it crosses the y-axis. All points have an x-coordinate and a y-coordinate. This number that you found here is the y-coordinate. That's where it crosses the y-axis at -1/8. Your x-coordinate, if you're on the y-intercept, your x-coordinate is always 0. All right, the vertical asymptote or topes. Now remember, the vertical asymptotes are zeros of the denominator. So remember, I did that here. Here's my zeros of the denominator. But what do I also need to know? That are not also zeros of the numerator, which means this -8 is not a vertical asymptote because it was also a 0 of the numerator. So the only vertical asymptote is at x equals 8. So the vertical asymptote is x equals 8. Now find the horizontal asymptote. So let's see, that goes by our degree chart. So let's see, the degree of the numerator is 1. The degree of the denominator is 2. So the degree of the numerator is less than the degree of the denominator. And what does that tell you? On horizontal asymptotes, the degree of the numerator is less than the degree of the denominator. Then the horizontal asymptote is y equals 0. So the horizontal asymptote is y equals 0. And like I said earlier, none of the problems will have an oblique asymptote. So let's see what this is going to look like. Again, if you wanted to, let's see what we know. It's going to have no x-intercept, which means it doesn't cross the x-axis, which doesn't look like any of them do. The y-intercept, it's going to cross the y-axis at -1/8. Here, this is going to help us a lot. This is the vertical asymptote is at x equals 8. And there's only one vertical asymptote. Look, here, this one has vertical asymptote at 8 and -8. So it's not that one. This one also has 2 of those vertical asymptotes. So it's not that one. Now look at this one. Its vertical asymptote is at -8. This one's vertical asymptote is at +8. So the only one that has that situation where the vertical asymptote is at 8 is D. Okay, it also has this horizontal asymptote at y equals 0, which is right there. Number 16. All right, same thing. So if you'll notice the numerator and the denominator, it's going to ask me all the same things. So let's go ahead and find the zeros of the numerator and the denominator because that's going to help us answer a lot of the questions. So since they're both squared, they're both quad. So go to quad. Let's find the zeros of the numerator. Let's see. A is 1. B is 2, and C is -3. So the zeros of the numerator are 1 and -3. All right, let's find the zeros of the denominator. So program quad. Again, in the denominator, A is 1, B is 4, and C is 3. So here's the zeros of the denominator, -1, -3. Okay, so the first question, what is the domain of the function? Remember, the domain of the function is the zeros of the denominator, which is -1 and -3, need to be excluded, which means in interval notation, You'll have negative infinity. Now, be careful here. Remember, when you're talking on the number line, and you're coming from the very far left end of the number line, you're actually going to run into -3 first, right? So you need -3. So negative infinity to -3. And then the numbers between -3 and -1 in union with -1 to infinity. So there's the domain. All right, to find the X and Y-intercepts, let's see. The X-intercepts are the zeros of the numerator, which is 1 and -3, as long as they are not also zeros of the denominator. So since -3 is also a zero in the denominator, then 1 is the only X-intercept, okay? So there is an X-intercept, let's just write this off at the side, at 1, 0. Okay, now, to find the Y-intercept, that means replace all of these X's with zeros. So and see what you have left. So if I have zeros in all of these X's, all I'm going to be left with, if I put zeros in here, 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 and here, it's just going to knock all that part out, right? If it's got an X and you put a 0 in its place, all of this part of this fraction is going to turn into 0 except the part that doesn't have an X, which is that -3 over +3 at the end. Okay, so -3 over +3 is -1. So let's see, the Y-intercept is at -1. So there are X-intercepts and Y-intercepts, so that's not right. That's not right, and that's not right, right? There's one of each. The X-intercept is at 1, 0. And the Y-intercept is at 0, -1. All right, the vertical asymptotes. Now, remember, again, from the notes, the vertical asymptotes are zeros of the denominator, so -1, -3, that are not also zeros of the numerator. So since, again, -3 is a 0 in both spots, this is not a vertical asymptote. Only the -1 is. So the vertical asymptote is x equals -1. Then it says find the horizontal asymptote. Now remember, the horizontal asymptote goes by the chart, and we're looking at the degrees. What are the degree of the top and the bottom? Equal. Since they are both 2, the degree of the numerator is equal to the degree of the denominator. And what does that tell me about the horizontal asymptote? When they equal, the horizontal asymptote is y equals the leading coefficient of the numerator over the leading coefficient of the denominator. So let's look at these leading coefficients. What's the leading coefficient of the numerator? Is a 1. And the denominator is also a 1. So the horizontal asymptote is 1 over 1, which is just 1. And there is no oblique asymptote. So let's look at what this one would look like. Let's see, it's going to cross, since the X-intercept is at 1, the Y-intercept is at -1. So let's see. This one, look where it crosses the x-axis. Again, you'll be able to make your graphs a lot bigger. It'll help a lot. Let's start off with the vertical asymptote. A lot of times that's easy. The easy way to eliminate some of the possibilities. The vertical asymptote is going to be that vertical line like this. And where is it going to be going? Through the x at -1. Well, look at this one. Where is this vertical asymptote? It's on the right side of this, so that's at +1. So that vertical asymptote is at +1. Where is this one? It's also at +1. Both of these vertical asymptotes are at -1. Do you see how it goes through the x-axis at -1, through the x-axis at -1? So those both have vertical asymptotes at -1. Where is the horizontal asymptote, which is the line that goes through like this? It needs to be going through the y-axis at +1. So look where this horizontal asymptote goes through. It's below the x-axis, which means it's going through at negative. This one goes through, if you're looking, and you can make your graphs a lot bigger online. So you can look through and see that that horizontal asymptote is going through at +1. How many are there? 2 more. All right. Let's find, again, before we start, let's find the zeros of the numerator and denominator, because that's going to help us in a lot of our questions. Let's see, they're not quads, so I don't need to use my quad program. They're just straight x's. So let's see, the 0 of the numerator comes from x minus 5 equals 0. Solve for x, so add the 5 to both sides, so x equals 5. So the 0 of the numerator, we'll just put it over here, is 5. The 0 of the denominator, so x plus 3 equals 0, subtract the 3. So x equals -3. So again, that's just the z. I wrote these over here because that's going to help us with a lot of our answers. Now, when it's talking about the domain, the first question, what is the domain of the function? Remember, the domain is every number except the 0 of the denominator, which means all the numbers on the number line except -3, which means -infinity to -3 in union with -3 to infinity. All right, the X and Y-Intercepts. The X-Intercept is the 0 of the numerator, which in this case is 5, as long as it's not a 0 of the denominator. And it's not, which means the X-Intercept is at 5, 0. All right, the Y-Intercept is going to be, let's see, if we plug in zeros in this for the x's in the function, it'll knock this out and this out, right? If you put zeros there, it's kind of like those just knock out. Your y-intercept is what is left over, which is -5 over 3. So it's the y, so -5 over 3 with the 0 in the x spot. Okay, so let's see. There's both. There's one of each. So the x-intercept is at 5, 0. The y-intercept is at 0, -5 thirds. The vertical asymptote is at the 0 of the denominator, as long as it's not a 0 of the numerator, and it's not, since these aren't the same. So the vertical asymptote is at x equals -3. The horizontal asymptote goes by the chart. So since the degrees are equal, right? The degrees are both 1, so the degrees are equal, which simply means the horizontal asymptote is at y equals the leading coefficient of the top and the leading coefficient of the bottom, which are both 1. So the horizontal asymptote is at +1, and there is no oblique. So let's use our asymptotes first to eliminate some of our choices. This is always a good one. The vertical asymptote is at x equals -3. So remember, you're going to want that dotted line going through the x-axis at +3. This one looks like it goes through the x-axis at +3. But look where this vertical asymptote goes through. It goes through at -3, so it's not that one. Same thing here. Look at this vertical asymptote here. Again, it's going through at -3, which means it's not that one. Now, this one's good because look at its vertical asymptote. It's at positive. Oh my gosh. I just eliminated the wrong ones. Oh, I'm having a hard day doing this, y'all. at -3, not +3 like I've been looking for. So actually these are the ones that are okay because their vertical asymptotes are at -3. So really, these are not okay. Y'all are going to have to forgive me on this, but I can't start over because we're almost done. So the vertical lines are at -3 on B and C, like we want them to be. Where should the horizontal asymptote be? It should be at +1. So remember, just ignore those x's. We're looking for the horizontal asymptote at y equals +1. Well, look, this one's at -1 because it's below. Look, that one's the one at +1. So it has the vertical asymptote at -3 and the horizontal asymptote at +1. So C. All right, last one. Okay, finding the domain, the X and Y-intercepts, the asymptotes, and all the good stuff to be able to identify this graph. So again, let's find the zeros of the numerator and the denominator. So let's see, the numerator is quad, right? It's x squared. So let's go to our quad. Program quad. A is 1, that's the number in front of x squared. B is the number in front of x, which is 2. There is no C, right? There is no constant, so it's just 0. All right, so the zeros of the numerator are 0 and -2. Now, the denominator's not quad yet because it's x cubed. So since it's x cubed, that means, look at all these terms. They do all have an x. So if I pull an x out, I'll put it, that will leave me with 3x squared minus 5x minus 2, which this in here is quad, right? Because now it's x squared. So let's plug that into quad. So A now is 3, B is -5, C is -2. So let's see. From this one, I'm going to have 2. Now, look at this, -0.3333. If that is turned into a fraction, it would be -1/3. So those are the zeros that come from this part. What is the 0 that comes from this? If you set this x equal to 0, you just get 0. So since it's x cubed, it's going to have 3 zeros down there. So 0, 2, and -1/3. 0, 2, -1/3. So what is the domain of the function? That means, and this one's not, it's giving you multiple choice, and it's not writing it in interval notation. It just gives you these 3 numbers. Those are what are eliminated. That's what x cannot be. So x cannot be 0, it cannot be 2, and it cannot be -1/3. So C. Now, what are the equation of any vertical asymptotes? Remember, vertical asymptotes are zeros of the denominator. So there's the 3 zeros of the denominator. But what's the stipulation? They cannot also be a 0 of the numerator, which means this one cancels out. Those do not make vertical asymptotes. So the only vertical asymptotes are x equals 2 and x equals -1/3. So those are where your vertical asymptotes are. Horizontal asymptotes. Let's see. The degree of the numerator is 2. The degree of the denominator is 3, which means the numerator is less than the denominator. And if you look at your horizontal asymptote chart, if the degree of the numerator is less than the degree of the denominator, then that horizontal asymptote is going to be at y equals 0. So the horizontal asymptote is at y equals 0. All right, the X-intercepts are zeros of the numerator. So there's your zeros of the numerator. Once again, that are not zeros of the denominator. So the only x-intercept is actually at negative 2. So it's going to cross the x-axis at negative 2. So negative 2, 0 is the x-intercept. All right? The y-intercept is, look what happens if you replace all of these x's with zeros. What does it do to the denominator? If you put 0 here, and 0 here, it will actually turn that whole denominator into 0, which means if you're replacing the x's and it turns your denominator into a 0, that simply means there is no y-intercept. Okay, so let's see what we can knock out with vertical asymptotes. There should be a vertical asymptote at positive 2 and negative 1/3. So if I'm looking at these, that doesn't help us very much at all. Because look, if this is, look, that's a 4. See how that, so which means that's at 2. So there is a vertical asymptote at 2, and then another one at negative 1/3. 2, negative 1/3. 2, negative 1/3, and 2, negative 1/3. So that helps me not at all. Neither does the horizontal asymptote, because it's at y equals 0. Well, here's y equals 0 right here. So it's also not helping me. They all have the horizontal asymptote of y equals 0. Now, let's see. What does this tell me? This tells me that there is an x-intercept at negative 2. Which also looks like it's not helping me, right? Because what's happening there, if crosses or touches the x-axis at 2. Well, there's 2. Looks like it's touching it there, there, and there. It all looks like they all touch the x-axis at negative 2. Now, here's where we're going to have a lot of help. What does this mean? There is no y-intercept, which means it doesn't cross the y-axis. Now, look at this one. Let's look here. So here's my y-axis. Now look, this looks like it's going to cross it, but look, there's a hole there. So it doesn't cross the y-axis. Look, this one crosses through the y-axis, so it's not that one. Let's see, this one, look, right here, it crosses through the y-axis, so it's not that one. This one also doesn't cross through the y-axis, which means there's a hole there also. So now, the way that you distinguish between, let's look, if we can actually type these into our calculator if we want. Let's think about what another distinguishing mark would be. What's the difference between these? Vertical asymptotes at negative 1/3 and 2. Horizontal asymptote at 0. Neither one cross the y-axis. Let's look. I'm trying to go to y equals here. Okay, so I'm trying to think of another way. So I just went to my graph and plugged it in. So I do get the D answer, but I'm trying to think of the way that we could look at this graph without, so it's going to be D because it has this shape, just like the D does, not like the A. Okay, and what I put in my Y equals is you have to think about it without having the factor that created the 0 in the top and the bottom, since they canceled each other, which would just be x plus 2 over 3x squared minus 5x minus 2, because the ones that created the 0 were these x's, so you wouldn't be able to have those when you typed in the graph, so because they canceled. So here's what you would put in your Y equals to get this. Okay, so that's what would narrow it down after we looked at the intercepts to being D instead, because if you type that into your Y equals x plus 2 over 3x squared minus 5x minus 2 and then graph it, you get the graph of the D solution.